So we should be able to get this through this segment a little bit faster now that we've gotten the hang of it. All right, so remember that cosecant is 1 over sine. Okay, and now that we've gotten the hang of what to do, right? When we're making this graph, first thing we do is we go to where sine is 0 and we put asymptote lines. Okay, sine is 0 at 0, pi over 2, and 2 pi, right? So when we come down here, I purposely put this one next to cotangent, right? Since cotangent is cosine over sine, right? We are going to end up with the exact same domain. Okay, so here was the domain for cotangent. I'm going to put an arrow down here. This is going to be the domain for, oh, actually, I guess it's on the next page. So that's going to be the domain for cosecant, which also has sine in the denominator. So it's, you know, where the function is undefined, which is determined by which trig function, which is in the denominator, that is what determines the domain. Okay, so cotangent and cosecant will have the same domain because they both have sine in the denominator. Okay, so keep adding my asymptote lines here. And then I have to look at where is sine 1, right? Sine is 1 at pi over 2. Sine is -1 at 3 pi over 2. The reciprocal of 1 is 1. The reciprocal of -1 is -1. Okay, and so then I'd have this, and I'd have this over on this side. Okay, and again, exact same thing happens that happened in cotangent when I'm close to 0. When I'm close to 0, I will have a value close to 1, or I'd have a value 1 divided by something close to 0, I would get very big. Okay, so over here, I'm very big in a positive way. Right, and then over on this side, I'm very big in a negative way. Okay, and sometimes it's nice to look at this with the sine curve on the same set of axes, right? Because this could help me see, like, here where sine is a half, its reciprocal is 2, right? I can see that, right, by like looking at these points. Okay, and anywhere that the sine curve is very close to 0, the reciprocal 1 over something very, very close to 0 is very, very large. Okay, so anywhere that sine is close to 0, I'm at this very, very large negative or very large negative value or very large positive value. Okay, and so again, I could continue this over here. So the sine curve does this. Right? And that's going to mean that its reciprocal does this. Okay. So I have the same exact domain that I had in cotangent. The range here is a little bit tricky. Okay, so remember that the range of the sine curve was -1 to 1 inclusive, right? I included 1. Okay. And in this case, the range is everything but what I have in red, with the exception of, though, the points 1 and -1. Okay, -1 and 1 will be part of the range of the sine curve and the range of the cosecant curve. All right, so anyway, let's answer some of these questions then. What is the domain? All right, so same as cotangent. All right, so I'll let you fill that in. as cotangent. Okay, so what is the range? Okay, well, I go from negative infinity up to -1, include -1, so that is closed. But then everything in red, other than the point 1, is not included as possible output for the cosecant curve. Okay, so here's the range for cosecant. And then the period, it does take me 2 pi radians, 2 pi units to complete a full cycle of the cosecant curve. Okay, so this from here to here is considered a full cycle. Okay, I have to have the part opening up and the part opening down to be considered a full cycle. Okay, and again, where is this 1-to-1? So if I try to say I am 1-to-1 from, say, 0 to pi, right, I'm not, right? If I were to draw a horizontal line from, 0 to pi, that doesn't work. All right, so in order to determine an interval where I'm 1-to-1, if I looked at this part that I am coloring here in yellow, right, and I'm only looking at this and that, right, then I would be 1-to-1. Okay, so how do I define that? I'm going to write it below here, but on your notes, I'll let you write it in the correct place. Okay, so the domain, I could include -pi/2. So I use a closed bracket. I'm not defined at 0 though, so I use an open bracket, union 0 to pi/2. Okay, so again, we're going to use this fact later in today's lesson. Close that. Okay, so moving on then to secant. Secant is 1/cosine. Okay, that means that secant is going to have the same domain as tangent, which was sine/cosine. Okay, so when I get down to secant, the domain of secant, actually here's where I wrote the domain of tangent. The domain of secant is going to be the same as the domain of tangent, since they both have cosine in the denominator. Right, so this is the domain of secant also. Okay, so I'll let you write that into the appropriate place in your notes. All right, and then again, I hope we've really gotten the hang of this. So if I came down here to where I want to graph secant, okay, so secant is 1/cosine. Anywhere cosine is 0, I need my asymptote lines. So the same places where I had asymptote lines in the tangent curve, which was every odd multiple of pi/2. All right, and then I say, okay, well, where is cosine 1? Because where cosine is 1, its reciprocal is 1. Where cosine is -1, its reciprocal is -1. Okay, and again, it might help to draw the cosine curve. I'm going to draw that in green here. Oops, I'm sorry. Sorry about that. It's got to go through 0. There's my cosine curve. A little ugly. Okay, so now in black, okay, same exact thing happens, right? I have the reciprocal. So again, I can see things like where cosine is a half, which happens about, again, my graph is sort of awkward. It's not a great graph, but here cosine is a half. Here I am, its reciprocal is 2. Okay, anywhere that I'm close to 0, I'm dividing by something really close to 0, which gets me a really large value. And my domain is the same as tangent. Same as the answer for tangent. All right, the range, right? Same exact range. Actually, I guess before I get too ahead of myself, let me finish this. Sorry about that. I'm jumping ahead, but finish it over here. There we go. Okay. Nothing in green other than the points 1 and -1 are included in the range. Remember, range is the possible y values, right? So everything that's in black, right? I'd have to look at the y values, right? For everything in black, nothing is included in these y values in between 1 and -1. Okay, so the answer for the range is the exact same answer that I had up above for the range of cosecant. Okay, I do include 1, -1, and I do include 1. That's why I use the closed brackets. All right, so that's the range. The period, again, the period would be the amount of time it takes me to get a full cycle. All right, so the full cycle is the up U with the down U. Okay, and so that would take me 2 pi to complete. Okay, here's an up U starting at -pi/2, and it takes me all the way to 3 pi/2 to get the other complete cycle. Okay, so that would be 2 pi units to complete a cycle. And then where am I 1 to 1? Okay. And 1 to 1 would occur if I went like this. Okay, so if I look at just what's in black and I put horizontal lines across, I would only hit this function here in black 1 time, right? If I restricted the domain from 0 to pi, but I can't include pi/2 because there's an asymptote line there. Okay, so I write the domain like this with the open bracket since I can't include it. So what we've got here in this segment is the graph of the other 4 trig functions, and then the critical information about those, which is the range, the domain, and the period.